Yes, everybody, let's get on with the problems. And what is the problem statement telling you here is find the Laplace transform of the following signals using the properties. We have seen the properties now. Okay, so keeping those properties as the reference or using the results of those properties, we need to be solving these problems. Otherwise, the solution gets bigger and lengthier. Okay, so to make the solution smaller and effective, okay, so we make use of these properties. Okay, you know, we have seen 8 properties of Laplace transform. So which property we would be using? Not all the 8 properties would be used for solving or for finding out the Laplace transform of a signal. Whichever is needed, we'll use those properties and we shall find the Laplace transform. Is that okay with you, everybody? The first problem is, everybody take down this. So that means they'll be giving us x of t. Okay. So we x of t or any function they can give us. Understand? So we need to be finding out what? We need to be finding out the Laplace transform for them. Understand that? Yeah. Everybody take down this. The first problem or the first function of t. See, the function of t can be given as x of t, f of t, or anything. Fine. So they have given the function or the signal. Okay, I've told you the signal can also be called as function because all signals are functions of time. Okay, so the first signal or the function is given by a plus b into e power minus bt. Okay, u of t. So this is the signal given. So for this signal, you need to find the Laplace transform. Understand that? Now, which property would be of help? Because there are scalars. Which are the scalars there? B is a scalar. And since it is negative, it very clearly says that this exponential is a decaying exponential, mind you. So this is decaying exponential. And we know what is the transform of a decaying exponential. That we have to remember if you have to make the solution short. Okay, so that is one thing. And other thing that you need to observe is the capital A and B here. Okay, they are scalars. Understand? So before we apply the Laplace transform to this particular signal given, we shall bring this particular signal in a proper form so that we can easily find the Laplace transform of that. Fine. So in the solution, what we can do is this. Everybody just start taking it down. We shall write f of t, the signal f of t, as what? A into u of t, the unit step function, plus b into e power minus bt into u of t. Everybody understand this point now? Okay. Now, what is that? We know okay. The first property that we have seen is by linearity property. What is linearity property telling you? It tells you that if there is a scalar along with the signal, that scalar needs to be separated and the transform needs to be applied only on the signal. Okay, so that is why we are using the linearity property. So by linearity property, the Laplace transform of f of t, which is given as capital F of capital S, as what? So this is it. First we do this, right? A u of t plus b e power minus bt u of t. So since we're using the linearity property, what we can do, we can keep this A out and we can apply Laplace transform on u of t. So this is what the linearity property tells us. Okay. Similarly, keep the scalar b out. Okay. Apply the Laplace transform on just the signal, that is e power minus bt into u of t. So this is how the things look like. Fine. Now what needs to be done? We know what is this? We know the Laplace transform of u of t, right? And similarly, we know the Laplace transform of this. That means we should just do this. Okay. We know that. Everybody write this. We know that what? Laplace transform of u of t is what? It's 1 by s. Okay. And the Laplace transform of e power minus bt u of t. What is the Laplace transform of this? Anybody? What is the Laplace transform of this? It is, see, if s is there, okay, since it is, what is Laplace transform of this? Let me tell you. What is Laplace transform of e power minus at? The Laplace transform of this is 1 by s plus a. Okay, since u of t is there, and along with u of t, since you have e power minus bt, the Laplace transform of the combination of these two signals would be 1 by s plus b. Understand? So this is something that we need to make use of in this particular function. Okay, so therefore f of s looks like what? So these two and this. Okay, so therefore f of s would be a into 1 by s plus b into 1 by s plus b. So this is what is going to be the Laplace transform of f of t given. Okay, here we have not only used the properties of Laplace transform, but we also are referring to the transforms of the basic signals. What is that? Everybody see here. We have seen a big list of Laplace transform basic signal here, right? So that also needs to be remembered. Okay, if you remember that list, okay, the things will get simple here. See here. So this list is what I'm talking about. Okay, so these are the transforms of the standard basic signals. Fine. So if you remember them, the things can be solved easily. Otherwise, no. Is that okay with you? So here t into e power minus at is there. Okay, for e power minus at, it is 1 by s plus a. Since t is there, it is s plus a squared. Understand? See here, sine omega t is there. If what is the transform of sine omega t? It is omega by s square plus omega square. Now with sine omega t, if e power minus at comes, what's happening? S is being replaced by s plus a. S is being replaced by s plus a. That means wherever this exponential comes along with any signal, okay, so the s needs to be replaced by s plus a. So that has what has happened here. Now see here, along with the signal u of t, e power minus bt is there. What is u of t? U of t Laplace transform is 1 by s. But since e power minus bt is there along with it, s needs to be replaced by s plus b. So that is what has happened here. Is everybody okay with that? So wherever the complex exponential, the decaying exponential is associating a signal, okay, so there the s needs to be replaced by s plus b in this case, or if it is e power minus at, it would be s plus a. So we need to remember the Laplace transform of the standard signals also. Yeah, that point. Now Take the second signal. This is very interesting, and it's not a straightforward problem. It is not a straightforward problem. So you need to be a little good with your basics. Now, everybody, just take down. In the first signal, they had given us the mathematical expression, right? See what's happening here in the second signal. Everybody, just copy down this signal graphically. We are representing it graphically. Okay, what is that? See here, everybody. So this is what the signal is. Okay, 0, 1, 2, 3, 4. Okay, and it's 0 throughout, and this is 1. Okay, and this is signal which is represented as x of t. Now they have given us the sketch of the signal. Okay, so we have to find out the Laplace transform of this using the properties of Laplace transform. See, in the first problem, they have given us the equation of the signal or the expression of the signal, or the signal is mathematically represented. Is it okay with you? The signal is mathematically represented. But here what's happening in the second problem, they have sketched the signal. So first thing that we need to do is we need to obtain the mathematical expression for this. Getting that point? So in the solution, let's say that first obtain the mathematical equation for the signal, for the given signal. So how to obtain that? We have to express this mathematically. Okay, using which basic signal this signal can be expressed mathematically is the question. Now everybody see here, which basic signal can be used to represent this mathematically is the question. Fine, so understand this, everybody. Let us use unit step function, okay, for this. So this is the note for you. We are using the unit step function for this. Okay, now everybody see here. It's very interesting also. Okay, if you understand this, the basic, it's very simple thing. But if you don't understand what I'm doing, you will just end up in confusion. Just see here, we are doing very simple thing actually. Okay, so can you tell me what is this signal? So this is 0. Fine. This is 1 and this is t. Which signal is this? Okay, this signal is 1 for t greater than or equal to 0 and 0 for t less than 0. That means it's a unit step function which is represented as u of t. Now the given signal is actually the combination of the shifted unit step functions, So can we have a unit step function which is starting at 2? Can we have a signal u of t which is starting at 2? That means if this is starting at 0. If this, let's look at this problem. That is a rectangular waveform is given and it's called as x of t. Okay, x of t is a signal which is continuous in time, okay, and it's a time varying signal. It's a rectangular waveform, and we have been asked to find out the Laplace transform of this rectangular wave or rectangular signal. So let's obtain this first. See, in the problems that we have seen so far, see the expression of the signal was given. Okay, for the first time, we are coming across a signal which is graphically represented. So we need to obtain the mathematical expression for this. Okay, the mathematical expression could be in terms of the basic signals that we have seen so far. We have seen unit step function, we have seen ramp, we have seen unit impulse. Okay, so the waveforms that are given can be expressed in one of these or as the combination of the basic signals we have seen before. Okay, any rectangular waveform for that matter can be obtained as a function of unit step function. What is unit step function? Unit step function is a signal, okay, which is 1 from 0 to infinity and 0 for t less than 0. Is that okay with you? Now, if this is u of t, how can we obtain a signal which is 1 from 2 to 4 is the question. Is that understood? So for that, we have considered u of t, because seeing this, we have understood that this can be constructed using the shifted versions of this unit step function u of t. So we need to consider the shifted version. Which is the first shifted version of this? You have to shift this by 2 units here to the right. Understand that? So this is starting at 0. Suppose if I want the same signals to start at 2. Okay. Why I want this to start at 2? Because see here, this waveform is starting from 2, right? So let's consider a unit step function which is starting at 2. Okay. So how does it look like? The unit step function starting at 2. Everybody see here? So let's consider the time axis again. Okay. So suppose this is 0, 1, 2, 3, 4, 5. It just goes on and on and on. Okay. So here what I'm trying to do is I'm trying to look at a unit step function which starts at 2 instead of 0. Okay, this is also 1. So this is starting at 2 instead of 0. So what would you call it as? So this is called as or represented as u of t minus 2. U of t minus 2 is u of t shifted to the right by 2 units. Remember this. Okay. Now, to obtain this, I need another u of t which is shifted by 4 units. Understand? So, shifting by 4 units, what do I get? Let's again consider this. Okay. So again, it's the time axis. See here, 4 is here. So let's take a unit step function which starts at 4 now. So this is 4. 0, 1, 2, 3, 4. So now it is shifted to 4. So if this u of t which is starting at 2 is represented as u of t minus 2, then u of t which is starting at 4 would be represented as u of t minus 4. Now, the task is considering u of t minus 2 and u of t minus 4, can you obtain this rectangular function is the thing that we need to look at. Is it possible to construct x of t by considering the u of t minus 2 and u of t minus 4? See, how can I obtain? I want a signal which is 1 from 2 to 4. That means a signal which is 1 from 2 to 4. Okay, from 2 to 4 I need 1. Okay, from 4 onwards, what are these two signals? From 4 onwards, these are all 1. From 4 onwards, both the signals are 1. So that means if I subtract u of t minus 4 from u of t minus 2, what will I get? See, it would be u of t minus 2 minus u of t minus 4. From 2 to 4, what it is? From 2 to 4, okay, this is 1. From 2 to 4, it is 0. So from 2 to 4, it is 1 minus 0. So from 2 to 4, you'll have 1. So let's do this and see what we get. Everybody, just look at this. What I'm trying to get is this. I'll do this. U of t minus 2 minus u of t minus 4. Fine. So what would be the result of this is what we are interested in seeing. Okay. So see here. So this is 1 from 2 to 4. Okay. From 2 to 4, it is 1. U of t minus 2. And it is 0. So it is 1. It is 1 minus 0 from 2 to 4. So what would it be? It would still be 1. From 2 to 4, it is performing what? From 2 to 4, it is performing 1 minus 0. Everybody understand that? Okay. So it would be 1 from 2 to 4. From 4 to infinity, what's happening? From 4 to infinity, see here. From 4 to infinity, this is 1. And 4 to infinity, this also is 1. So you are performing 1 minus 1 from 4 to infinity. See here, you are performing 1 minus 1 from 4 to infinity. So this is what we are going to get. So this is your x of t. Okay. So x of t was given as the signal, this, the graphical representation. So what we have done now is how to represent this x of t in mathematically in terms of u of t is what we have seen. So this exercise needs to be done. So you can do the whole stuff, or just by seeing this, if you are able to write, you can write, not at all a problem. Okay. So therefore x of t, therefore x of t can be mathematically represented as what? X of t equal to u of t minus 2 minus u of t minus 4. So this is what is our x of t now. So from the given graphical representation, we are representing the signal in mathematical form so that it becomes easier for us to apply the Laplace transform. Now, which is the basic signal? Which is the basic signal? U of t is the basic signal. Which operation is performed on u of t? Which operation is performed? The time shift operation is performed. Okay, so which property we are going to apply, because they have asked us to find out the Laplace transform of these signals by using the properties of Laplace transform. Everybody should be understanding that. So we are using the properties of the Laplace transform. Okay, so which property holds good here? T minus 2, T minus 4. That means it is being shifted in time. See, u of t is shifted in time by 2 units. U of t is shifted in time by 4 units. Understand that? So that's why we need to use time shift property. Everybody is able to understand that? Okay. So how does the time shift property looks like? Everybody just see here. The time shift property looks like this. If you have a shift minus t naught, that shift minus t naught needs to be represented here on Laplace domain, e power minus t naught s, x of s. So see here, this example is taken. If it is u of t minus 2, Laplace transform u of t minus 2 is Laplace transform of u of t accompanied by e power minus 2s. E power minus 2s, because minus 2 is the shift here. Is that okay with you? So what do you think it is going to be? We shall see now. Okay. Now, applying Laplace transform. So applying, everybody just take down this. Applying Laplace transform implies Laplace transform on x of t equal to Laplace transform on u of t minus 2 minus u of t minus 4. Fine. Now, what is Laplace transform on x of t? It is capital X of capital S. Understand? And how can we write this? We can write this as Laplace transform on u of t minus 2 minus Laplace transform on u of t minus 4. Which property is used here? So we have kept one out and we have applied the Laplace transform. This is by linearity property. So this we have done by linearity property. Okay. Also, we know that by time shift property, so we are using time shift property of Laplace transform. Laplace transform of what? Let's say this x of t minus 2. Let's write the generalized property is given as e power minus t naught s into x of s. So what is x of s here? X of s is the Laplace transform of x of t. So similarly, what is x of t here? X of t is u of t. What is Laplace transform of u of t? Laplace transform of u of t is 1 by s. Understand that? So therefore, so this call is as equation number 1. Okay. Therefore, equation number 1 implies x of s is equal to, okay, e power minus 2s into 1 by s. Okay, minus, now the shift is minus 4, so it is e power minus 4s into 1 by s. So just take 1 by s out and write the simplified Laplace transform. Therefore, x of s is given by 1 by s times e power minus 2s minus e power minus 4s. So this is what is the Laplace transform of the rectangular function given, that is x of t. Okay, so Laplace transform of the given function is this rectangular function x of t. We obtain the mathematical representation of this, okay, as this, and then we applied the time shift property of Laplace transform to obtain this Laplace transform expression. Everybody is okay with that? Now let's go on with another problem. Okay, copy down this, everybody. Problem number 3 now. Problem number 3. So what is it? X of t is now given as what? A into e power minus t minus at into cos omega naught t plus theta into u of t. Understand this? Now we need to see how to express this cos a plus b form, because I know what to do if cos a is there or cos b is there. Cos theta I know, but it is cos a plus b form. Understand that? So I don't want cos A plus B form. I want cos A or sin A. Understand that? So first, let's deal with this. So what is this particular function? This is e power minus 80. What is this? This is decaying exponential, and this is sinusoidal function. And what is this doing here? This u of t is the unit step function. It says that what is u of t doing? U of t is saying that this particular function exists from 0 to infinity. Okay, so let's see that in detail now. Okay, so before going into further details, let's express this cos omega naught t plus theta in the required form. Okay, so for that we need to know this. Okay, everybody take this in the solution. We know that cos a plus b is what? Cos A plus B is given by cos A cos B, okay, minus sin A sin B. Okay, so therefore I can write the given expression as what? Therefore I can write x of t equal to what? A into e power minus at. In the bracket, let's bring in this cos a plus b form. That is cos omega naught t cos theta, okay, minus sin omega naught t into sin theta. Okay, then you have u of t here. Now everybody very carefully listen to this. A is what here? A is a scalar, right? A is a number. Now, which among these are numbers and which among these are signals need to be considered? Okay, so how can we identify a signal? Okay, and how can we identify a scalar? Okay, see here, the functions of t, the parameters which are functions of t are signals. That means see, e power minus at is a signal, cos omega naught t is a signal, but cos theta is not a signal. Why cos theta is not a signal? It's a number. It's a number like a. Why? Because it's not a function of t. So entities which are not functions of t are not signals. In the same way, sin omega naught t is a signal. Okay, sin theta is not a signal, it is just a scalar. So according to linearity property, what we do? We take out the scalars and apply the transforms only on the signals. Understand that? See here. So the functions are this, and this. What are these? These are signals. Okay, these are all signals. S is equal to signal. Okay, A is what? This A, then this. What are these? These are all scalars. Okay. So this needs to be understood. So scalars, let's keep out and let's just apply the transform on signals. Is everybody okay with that? Fine. So just start applying the transform on signals now. Everybody start going. So we have identified which are signals and which are scalars. Now the job is to apply the Laplace transform on the signal, separating the scalars out. Okay, So let's do this. Keeping out the scalars, let's say. Keeping out the scalars, okay, and grouping the signals together. So this is what we are going to do. So how does it look like now? Everybody just go on. So therefore, x of t implies x of t is a is a scalar, cos theta is a scalar. Okay. These two along with e power minus at cos omega naught t into u of t. Okay, minus a sin theta into e power minus at sin omega naught t into u of t. So this is how we need to group the things. Is this okay with you, everybody? Now what we need to do after this? After this, what we need to do? So we need to just apply the Laplace transform. Okay, so we have brought the signal x of t, which was sinusoidal in nature. Okay, we have brought that into the required form, and we know what is the Laplace transform of these. Understand that? Okay, now here, if you write u of t or if you don't write u of t, then also it's fine. U of t, okay, in both the places. Okay, what they do, they are they just define the range. They define the range from what? 0 to infinity. Understand that? So this u of t is just a range defining function. Okay, so you'll be applying Laplace transform only on these, the standard transform. If u of t is there, okay, then it is just a range defining function. So we are applying transform on only these. Get that? So if you write u of t or if you don't write u of t, that is not going to make a difference, because anyways the standard transforms or the transforms we are applying go from 0 to infinity. Is that okay with you? Now applying transforms, now applying Laplace transform. Implies Laplace transform of x of t is x of s. Okay, then a cos theta, fine, is kept out. Okay, then what we can do, we apply Laplace transform. So let's write it once again, otherwise you'll be skipping a step, you may get confused. Okay, so let's apply the Laplace transform like this. What is that? Laplace transform we are applying on x of t. Okay, and we also are applying Laplace transform on this. I'll just try copy and paste this. Okay, everybody, you can just repeat this. Yeah, everybody just repeat this once again. I've just copied and pasted because I had the opportunity of doing that. Okay, now let's take out the things which are not required. Yeah. So by linearity property, by linearity property, what we can do, we can keep the scalars out. Okay, that is a cos theta we can keep out and apply Laplace transform only on e power minus at. Okay, uh, e power minus at cos omega naught t u of t. Fine. Similarly here, we keep the scalars out and apply Laplace transform only on e power minus at sine omega naught t u of t. Fine. See here, by standard transforms, we know that everybody just, so this call this as equation number 1. Okay, we know that Laplace transform of cos omega naught t u of t is what? Cos omega naught t u of t is this Laplace transform of cos omega naught t only. Okay, so let's not confuse with that extra u of t which is there. Okay, what is this? This is s by, okay, s square plus omega naught square. Okay, and I know that Laplace transform of sine omega naught t u of t, which is as good as Laplace transform of sine omega naught t. Okay, because u of t is just a range defining function. What is this? This is omega naught divided by s square plus omega naught square. So we know these two functions from the standard transforms that we have derived earlier. Okay, now what would happen now? Everybody, also, what happens if we apply Laplace transform to e power minus at cos omega naught t? So what happens? Wherever s is there, that needs to be replaced by s plus a. That is what is the rule. Okay, if you have an exponential e power minus at, so it would become this. Everybody understand that? Now, what would happen to e power minus at sine omega t? And Laplace transform of e power minus at sine omega t. What is this? Wherever s is there, that needs to be replaced by s plus a. That's it. Okay, so it's omega naught divided by s plus a squared plus omega naught squared. See, what's happening here is this. See, Laplace transform of cos omega naught t, I know it is s by s square plus omega naught square. If you bring a exponential e power minus at, which is decaying exponential, then this would become s plus a by s plus a whole square by omega naught. That means s here is replaced by s plus a. Similarly, s here is replaced by s plus s. So if any signal is accompanied by the decaying exponential, then in the Laplace transform of the signal, s needs to be replaced by s plus a. Understand that? Okay. So with all these results, how would this equation number 1 look like? Is the question. Okay. So therefore, equation number 1 implies Therefore, equation number 1 implies what? You have a cos theta and Laplace transform of this. That means this needs to be brought in this place. Okay, and this needs to be brought in this place. Okay, so write that. How would equation number 1 look like if it is so? Therefore, equation number 1 looks like this: x of s equal to, okay, a cos theta was there already as the scalar. Okay, along with that you have s plus a divided by s plus a squared plus omega naught squared minus the second term a cos theta is sorry, a sin theta is there, right? A sin theta, then you have omega naught there. Okay, a sin theta into omega naught divided by s plus a square plus omega naught square. So this is how the things turn out to be in the end. Is everybody okay with this? So this is what is the result going to be. Fine. Now we can take another problem. Okay, everybody take down this. That's problem number 4th for you. The 4th problem is this. What is that? X of t is given by what? Sine square omega naught t into u of t. So wherever this u of t comes along with the function of t, okay, then it is just a range defining function. What actually is given is sine square omega naught t is given. Understand that? So it means that here, so in the solution I'll just give you the meaning of this. It means that x of t is sine square omega naught t for t greater than or equal to 0 is the meaning of this. So which is the signal there? Signal is just sine square omega naught t. But you can, if you can remember, we nowhere have the sine square theta or cos square theta as the function, as the standard signals. See here, the standard signals that we have seen, I'll just show you that. Okay, the standard signals we have seen are these. Okay, and nowhere we have got sine square omega naught t or cos square omega naught t. So if the squares are there, we're not good enough to apply Laplace transform. So somehow I need to express that sine square theta in a proper form so that it becomes easier for us to apply the Laplace transform. Okay, so what is the how can I, since sine square theta is not there, so I cannot just move on with this square term here. I need to somehow eliminate this, okay, to have a signal which is suitable to apply the Laplace transform easily. Okay, so how can I deal with this? Okay, that is this. Here we know that if we have sine square theta, okay, it is given as 1 minus cos 2 theta divided by what? 2. So this is what we have. So since sine square theta will not help us, try express sine square theta in this form. Okay, if 2 is there, it is time scaling, I know what to do with time scaling using time scale property, but I don't want to deal with the square term because I don't know what to do with the square term. So to eliminate this square term or to express this in different form, we have used this form, okay, of the square term. Therefore, x of t can be written as what? Therefore, x of t is given as what? Half you can keep out. Fine. Then it is 1 minus cos 2 omega naught t. So this is what is the thing. Okay. So what is there here? There is a u of t. Fine. So further what I can do? Further I can represent this as x of t equal to half you can just keep out and you can say this is half u of t. Yeah, you can bring in half, not a problem. Then minus half, okay, cos 2 omega naught t into u of t. So what did I say? If u of t is there with another function of t, then you can just neglect that. Okay. So this further implies that the signal that we are considering is just this half u of t. This u of t is being considered because this is not a function of t. So let's consider u of t with this scalar. But here, this u of t is with another function of t. So you can just neglect that u of t. Okay. And you can write that as cos 2 omega naught t. So this is the way we can deal with the representation. Understand that? We will go beyond this, or I request you all to go beyond this and get me x of s. Okay, that x of s that you get should be in this form. Everybody, you can try this yourselves before you come to the next class. Okay, so here it is straight away. What is Laplace transform of u of t? It is 1 by s. What is Laplace transform of cos omega naught t? And what is Laplace transform of cos 2 omega naught t? So if you can know that, so the Laplace transform would happen to be this 2 omega naught square divided by s into s square plus 4 omega naught square. Okay, so try get this yourselves. Okay.